Let us look at proposition number 114 of book 10 of Euclid's Elements. The proposition says, if an area is contained by an apotome and a binomial straight line, the terms of which are commensurable with the terms of the apotome and in the same ratio, then the side of the area is rational. So let's begin. Let an area AB by CD be contained by AB an apotome and CD a binomial straight line. Now we divide CD into its terms CE and DE such that CE is greater than DE. And let BF be the NX to AB. And we do it in such a way that the terms are in proportion. AF is to BF is equal to CE is to DE. Now we construct G such that the square on G is equal to the rectangle AB by CD. Then what the proposition says is that G is a rational. And with this itself, we know G is the side of AB by CD. So main thing we have to prove is that G is rational. Okay. So we set out a rational straight line H to CD. We apply a parallelogram equal to the square on H, producing KL as breadth. CD is binomial, H is rational, that means H square is rational. So which implies KL is an apotome. The breadth that is produced by applying the square on a rational straight line to a binomial is an apotome, and that is KM. Now let KM and ML be the terms of the apotome. Let Km and ML be commensurable with CE and DE, and Km is to ML is equal to CE is to DE. Km is to ML is equal to CE is to DE, but CE is to DE is equal to AF is to BF. So which means we can write it like this. Km is to ML equal to CE is to DE is equal to AF is to BF. Or alternately, we can write it as, with respect to Km is to ML and AF is to BF, we can write it as AF is to Km is equal to BF is to ML. So we can again write this as AB is to KL is equal to AF is to KM. So how did this come? Because if you look at BF is to ML, BF is to ML, and AF is to KM is the whole is to whole is equal to part is to part. That means the other two parts are also going to be in the same ratio. So the other two parts are AB and KL. So we have AB is to KL is equal to AF is to KM. Since AF is commensurable with KM, how did this come? Because here if you notice, CE is commensurable with AF and Km is commensurable with CE. So Km is commensurable with CE, which is in turn commensurable with AF. That means AF and Km are commensurable, which implies that AB is also commensurable with KL. So AB is to KL is equal to AB by CD is to KL by CD. Think about this carefully. If we multiply AB and KL by the same thing, then the ratio does not change. That's the way to look at this. So, which means AB by CD is also commensurable with KL by CD, because AB is commensurable with KL. And since square on H is equal to KL by CD, implies AB by CD is commensurable with H square, because AB by CD is commensurable with KL by CD. And since KL by CD is equal to H square, we can say AB by CD is commensurable with H square. Now, G square is equal to AB by CD. Again, we can say G square is commensurable with H square because AB by CD is commensurable with H square. And since H square is rational, and because of this commensurability, G square is also rational. So G is rational. And G is the side of AB by CD. Just now what we have proved is that if a rectangle is contained by an apotome and a binomial straight line. Now remember, apotome and a binomial straight line, they are both irrationals. But the area contained by them is a rational area. So the corollary says that it is clear by this that it is possible for a rational area to be contained by irrational straight lines. So that is proposition number 114 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.